Have you ever been to the beach and accidentally swallowed some seawater? You already know it's incredibly salty. Not just a little salty, but overwhelmingly, aggressively salty. And it makes you wonder why. Here's something fascinating. If you could somehow remove all the salt from the ocean and spread it evenly across all the land on Earth, it would form a layer hundreds of feet thick, about the height of a 40-story building covering every continent. So where did all that salt come from? Did the Earth just start out this way? The answer is a story that began over 4 billion years ago, and surprisingly, it starts in the sky. When it rains, the water falling from the clouds isn't perfectly pure. As it moves through the atmosphere, it absorbs carbon dioxide, turning into a very weak acid. When this slightly acidic rain hits rocks and mountains, it slowly begins to break them down. This process releases tiny amounts of minerals, including sodium, but sodium is only half of what makes salt. The other half, chloride, comes from a much more dramatic source. Billions of years ago, massive volcanic eruptions released gases rich in chloride into the atmosphere. Over time, those gases dissolved into the oceans. Now you have both key ingredients: sodium from rocks and chloride from volcanoes. Rainwater carries these dissolved minerals into streams, and rivers transport them across the land until they eventually reach the ocean. This brings up an interesting question. If rivers carry these minerals, why don't they taste salty? The truth is, they do contain dissolved salts, but in such tiny amounts that our taste buds simply can't detect them. The real difference is what happens next. Rivers are always moving, always flowing somewhere else. But the ocean is like a giant basin, a final destination. Water flows into it, but the main way it leaves is through evaporation. When the sun heats the ocean, water turns into vapor and rises into the atmosphere to form clouds again. But the salt doesn't go with it, it stays behind. So, over billions of years, rivers kept delivering tiny amounts of dissolved minerals, and evaporation kept removing only the water. Little by little, the salt built up. Drop by drop, the ocean became salty. But that's not the whole story. Deep beneath the ocean's surface, there's another powerful process at work. Seawater seeps into cracks in the Earth's crust, where it encounters extremely hot rock. This superheats the water and triggers intense chemical reactions. The water exchanges minerals with the surrounding rock, becoming rich with new elements, and then bursts back into the ocean through hydrothermal vents, often called black smokers. These vents act like natural chemical refineries, constantly reshaping the composition of seawater. At this point, you might be wondering, if minerals are constantly being added, why doesn't the ocean just keep getting saltier and saltier? The answer is balance. While salts are always entering the ocean, they're also being removed. Marine organisms use minerals like calcium to build shells and skeletons. Some salts get trapped in sediments on the ocean floor. Others are left behind when shallow seas evaporate, forming vast salt deposits on land. Over long periods of time, what comes in is balanced by what goes out. So the next time you taste that salty ocean water, remember, you're not just tasting salt. You're tasting the dissolved remains of ancient mountains, the chemical traces of early volcanoes, and billions of years of Earth's history, all perfectly balanced in one vast, incredible ocean.